got a whole lot to throw at you. I probably feel like the whole fire hose that everybody's already talked about today. But at the same time, with the time period, we're only going to get to scratch the surface. So there's a ton of this to go over. So we'll get started. Real quick about me, 10 seconds. I'm a systems administrator at Rockwell Collins. Been using SaltStack since about 2014. If you do GitHub, I'm Lomero or Lomero, however you want to say that. On GitHub, that's my handle. So maybe we've talked on a PR or an issue on SaltStack or something before. Okay, so testing. Who tests their salt states before they go to production? All right, not too bad. Hopefully more of you. I'm that guy that when the presenter asks that, I still sit there with my arms crossed and don't raise my hand even if I'm doing it. So hopefully some of you are that way too. So let's quickly cover some manual testing methods, or these are kind of the way previously I manually tested. So what I'd like to call a complete test strategy, where you use like state.apply with test true to make sure that the state's going to do what you're expecting it to do from a rendering perspective, and then actually applying it and manually checking it. And then second type of test strategy, I kind of call a partial test strategy, which is using mock and or just show SLS to basically just test rendering and keyword arguments, that sort of thing. So now, so the problems kind of that we ran into that got us down this path, we had a strong desire to just implement DevOps methodologies that hopefully lots of you guys are looking to do too with, we have a pipeline for our SALT code. We wanted our tests documented. We wanted to use as much automation as possible, those sorts of things. But really when it came down to it, it was just about code quality. So, oftentimes if we'd make a mistake in a state, and if we weren't testing it, then that would get out into production and you'd find it later, that the state didn't do what you expected. You waited all that time for it to go through the pipeline. It'd get published out to the masters, and then it didn't render, what have you, it didn't work. On top of that, we'd have lots of masterless type systems that use SALT to then update themselves to pull down new copies of our master bundle, if you will. And if you screwed something up in their pillar or in the state, then obviously you broke that automation, and now you have to go manually fix those. And so those types of things were really what got us into that we needed to be testing before stuff made it out to production. All right, so some of the solutions that we worked through. So just our first, that biggest hurdle that we ran into was rendering. I would say that's probably where we make the most mistakes, or I feel like people make the most mistakes, or just fat fingers, mistypes. If you've got new people to SALT, maybe they use a tab instead of a space in a pillar file, what have you. And so catching those things were kind of our top priority. And to do that, we use pytest. And so we'll talk about that here in a second. And then second was actually doing that a state does, or a formula does exactly what we want it to do from the state that it applies to the system, that it actually, even though everything came back green, did it actually do what we expected? Did the modules function the way they expected, that sort of thing? And so I'm going to show some snippets of code, etc., but I have a Git repo, SaltConf 18, that's got all these tests out there in it. You can go pull it down, hopefully kind of get you started down this path if you haven't used any of these tools to maybe be able to implement them in your environment. All right, so like I said, pytest was our step one, and it was mainly about rendering. So we wanted to catch render errors before they were out on the masters, because like I said, that was the majority of our problems. So pytest is just a framework for testing Python code. And it allows you to write tests in Python, and then you can parameterize those tests to pass, all kinds of different options to them to iterate over different instances of however you want it to do it. So basically, the way we use it is to all of our Jinja maps and our formulas, we filter on both OS family and then major release to just to apply different values to possible package names or what the state's going to do, what have you. And so those are really what we, those options are really what we pass in to the tests from our perspective. So to get pytest set up, you just need the minion, and then you can install pytest with pip or a package manager. It just needs to be in the Python instance that has salt is installed into. So like on Windows, you want to use the pip.installed module. That way it'll install it into the bundled Python version that the minion comes with. Okay, so there's three little components to a pytest setup. There's a setup CFG, there's the conf test, and then there's your actual test files. So the setup CFG kind of just does some basic configuration of pytest. Really the only thing we use this for is, so pytest, when you run it, is going to try to find every Python file that starts with the word test in that subdirectory, and it's going to try to execute it. So the biggest thing we use that for is to exclude directories where we have files that are Python files that start with the word test, but they're not really pytest files. Something like maybe a Nagios test or something like that happens to be in a repository. So that's really all we use it for. Now conf test is where you create kind of the base of your test. It's called a fixture. So that's where we're going to create the salt collar API object that we're then going to utilize in our actual tests. Okay, so here's an example of a test file. This is going to just run show SLS. So like I mentioned earlier, our maps are all basically centered around OS version and then OS family and major version. So that's what we're going to pass in here to test this particular state. So the parameterize is that option. So this test would be run 3 separate times. Once pretending to be Red Hat 7, once is Windows 2016, and once is Windows 2012. So then the test just sets up the minion object, sets the grains to those particular OS versions that we're passing in, and then it just runs the show SLS, pretty simple, and compares the output to make sure that it's a dict or an order dict. So I believe it's 2016.3 and before returned a dict, and all the newer ones return in a salt utilsodict, order dict. So we're comparing both of those because we still do some testing against 2016.11, which returns a dict. So really, you could modify this to do, if you were filtering on other grains or doing other things, you could modify it to pass in whatever you want and change the minion to pretend to look the way you wanted it to test rendering. So that's really all this test is about, is checking the rendering of that particular state to make sure that there's no syntax errors. So now if we went to go run this test using pytest, so we would just call pytest, and we're going to, in this instance, I'm passing the parameter, the serve salt state 1 path. That will tell pytest only look in that folder for tests. And you can see that then it found 3 tests, which correlated to the 3 parameter options we saw previously, and they all passed. So it ran show SLS for each one of those grain combinations, resetting that, creating that minion API version, updating the grains to make it think that it was Red Hat 7, even though maybe I'm running this particular test. You can tell I ran it on a Windows box with the prompt there. So it said, you're really Red Hat 7, now render this SLS based on your grain data. So that way I can test any OS that I want to render for from any other OS, basically. So now a failed test. So out in the repo, there's state 1 and state 2. State 1 has no errors, so it should render for you if you were to pull that down and test it. State 2, on the other hand, does not. It's got a tab in it instead of a space, so if we were to run it again, now it shows failed, and you'd actually see it failed 3 times. I kind of snipped it out just so it'd fit on the slide, and it'll show you basically as if I were to run show SLS from the command line, and you would see that output, that there's a Jinja error, that there's a tab instead of a space. So pytest just consumes that output and reports it back to you. Pretty simple, hopefully. And I know I'm flying through this, but there's a lot to cover, so I'm going to try to, I'm imagining there's going to be questions. So now, PyTest pros and cons here. So the pro, it's fast, relatively fast. You can, I can pretend to be a minion and run a test, like I said, from my workstation or from a server, and pretend to be some other server type. And so it's fairly efficient from that perspective. Another huge plus for us was that I could cookie cutter tests. So I can create that test file you saw with one of my cookie cutters that my devs might use to start off a formula. So they automatically get render testing in their package, if you will, their formula package. That way you don't have to depend on them to go actually do anything. So you at least get some level of testing just as long as they're trained to use your cookie cutter. And now it does have some cons. The biggest one being that the minion that you're running that test from is the only one that it's going to test rendering on. So if you've got 2017.7 installed on this system that you're running PyTest on, obviously 2017.7 is what it's going to be a test against. So we solve that by in our Jenkins system, we have slaves that have each different minion that we support installed, and then we run all of our PyTests through each one of those minions so we can test rendering against all the different minions that we have in our environment from 2016.11 on up for us. So then it just doesn't validate that we did what we wanted it to do. Our rendering's great, but did it work? So that kind of obviously then led us to what I'm going to talk about next, which is Test Kitchen. And then like any kind of test, it's only as good as the test you write. So you can extend PyTest to do much other, you could apply a state and then use PyTest to do the same thing we're going to talk about with Test Kitchen. PyTest could do the same thing if you really wanted it to. And we also can use it, I didn't mention, I apologize, that you can use it, we'll use it for pillar rendering too. So you can, which again, like I mentioned, was a big one for us, because if you screw up pillar, then you can screw up a lot of other things for your system. So there's examples in the repo about how to test a pillar. So it's set up for, in our particular instance, to, we can pass a specific minion ID and a set of grains, and we can either just say, did all the pillars for that combination render? And if so, we're good. And then we can there's also a test to actually test a specific pillar key, and then it came up with a specific value. So if you've got a set of pillars perhaps that a lot of people modify, and you know specific ones need to come out with specific data, you can help make sure nobody messes that pillar up for everybody else by having those tests in your repo to then run when a commit is made to catch those errors. Okay, so Test Kitchen. Now this is, like I said, we moved into Test Kitchen after PyTest because PyTest did a great job of doing rendering, but then when we ran into issues where the state didn't actually do what we wanted, then that was what we needed something else, another tool for. So obviously we could, I still have devs that do this, that they write a state, they commit it, their rendering states, the rendering tests pass, and then they actually go out to a dev system and they apply the state and they look to see if it worked. And if it didn't, then they go back and they make changes and then they commit it again, wait for our pipeline to run all the tests, send it through, and they do that iteration over and over and over again instead of making use of the tools we've provided them. So that's one, I'll talk about it in the cons. That's one of the things with Test Kitchen that's harder, is your devs do have to make use of it. So it's not as easy to just template it and give them tests right out of the gate. So the prereqs for Test Kitchen, it is a Ruby app, so you may have to learn some Ruby. That kind of go towards like what was spoken about earlier today about some development there. If you're not familiar with Ruby, you may get a chance to learn some, which I actually think I listed it as a con, since I think probably most people in here are Python fans, but like I said, it could also be seen as a pro. Then Kitchen Salt is a gem owned by the Salt organization that's used for telling Test Kitchen to apply states to a platform. And then there's just a couple of other gems there that we're going to use. ServerSpec actually does the tests, and then Kitchen Verifier is used to execute ServerSpec through either an SSH session on a Linux box or a WinRM session on Windows host. And then there's tons of other plugins for Test Kitchen for all different types of cloud providers for you to create your platforms in Amazon, VMware, Hyper-V, Azure, wherever you want to create platforms to do your testing. So similar to pytest, Kitchen has one configuration file, and that's the kitchen.yml file. And this is where you'll define all your platforms, your suites. So what your suite would be analogous to is your actual state that you're wanting to test or set of states. And then your verifiers, which is for, in this case, ServerSpec is what we're using to do our actual tests. And then your driver would be, like I said, EC2 or VMware or what have you, whatever Vagrant, however you want to create VMs to do it. And then you can create overrides in a kitchen.yml.local, and that way if you have like a Jenkins box or something that's running your kitchen tests for you on a commit, then you can have developers create overrides in their local file that then don't get committed to the repo. That way if, say, they want to use Vagrant to do a test, they can locally, but maybe you're using Amazon to do your tests through your pipeline. Okay. So Kitchen's got 6 phases that it runs through. Whenever you run a kitchen test, it's going to destroy any from the command line of just kitchen test. That's the actual would be the actual call. It would destroy any instances that have already been created for that platform suite, and it's going to create a new one. It'll converge it, which means it's going to apply the state, and then the setup piece doesn't necessarily apply here, but I included it just for informational purposes. And then it's going to verify it, which is where it'll run the ServerSpec tests that you define. So. And then it will clean it up if everything succeeded, or you can configure it to always clean it up even if it failed, or it'll, like I said, if it fails, generally it'll leave it out there, and that way you can go look at it manually if you need to, or run, change code, run the converge again to reapply the state, changes you've made to the state, then run your verify again, and kind of iterate through that without having to start all the way over from scratch of creating a new VM and everything. And then, like I said, each step you can run manually. So I can run kitchen create, first particular platform suite, and it'll go provision that VM, and then not do anything else. That's all it's going to do is provision it. Then if I were to run converge, it would create it, apply the state, be done. And if I run verify, then it's going to create it, apply the state, and then run my tests. So I can step through each one of those manually or to whatever way I want to get at it. Typically, once you put it into like Jenkins or something, you just run kitchen test to do the entire process. Okay, so we'll look at a test file for an example test here for a test kitchen. So this is using ServerSpec here, and this is all Ruby code, like I said, unfortunately. Excuse me. So this is going to, if you were to go look at it at state 1, out in the example repo, state 1 just simply manages a file in a particular folder depending on the OS defined in the map. And so this test basically just says, so the language of our spec is, use describe to say what you're going to test, or kind of just a description of it. So for this particular one, we're saying, this file, and then we set it. This is I apologize. This is a little more complicated way of writing an RSpec test to give us a little bit better output in the end. So if you were to go look at server spec documentation, you'll see that server spec, the way they show it in their documentation is just like, they'll say describe file, the file, like where my line says subject, and then they'll say it exists, or it should exist. And that's kind of the generic way of writing an RSpec test. And so what that'll do once you run it from an output perspective, it'll just say the file should exist. So using this type of language here where I'm being more descriptive of what I'm testing. So it doesn't necessarily apply when I'm just saying, does this file exist, and it has some specific content, but say you're doing like some service, like McAfee service, like the McAfee agent service where its name is MySVC. Having an output say MySVC is running may not necessarily mean anything to anybody. So I can use my describe here to say the McAfee agent service, MySVC, should be running. And that way it just gives me more flexibility and control from the output perspective, which as far as automating and actually testing is really irrelevant. But if you get into using it to provide documentation that you want to hand to somebody to say, here's what all my salt is doing in a human readable language, then that can make a difference. So in the repo, it does show both. It shows both ways of doing it. And like I said, this is just kind of more of an iteration that we've moved into from a documentation perspective. So now if we were to run that test, or kitchen test for state one, so once, so in my kitchen YML, you'll create platforms. So when you think platform is like Red Hat 7, Windows, Ubuntu, that type of thing, and then you'll set up a suite, which like I said is your state. So for state one, the suite name is just state one, and then we have out there in the repo, example repo, and then there's a number of platforms. There's several Windows platforms, there's an Ubuntu platform, and there's a Cent platform. And then that suite is then associated with the different platforms I want to test with. So on this particular one, you can see it's running state one on my Linux Cent 7 with Salt latest. So that's all just a description of my platform. So that particular platform, Cent 7 Salt latest on EC2, it's just an arbitrary naming that I did to make it explicit on what it is. It's a Cent 7 box. It's running the latest version of Salt. So it's not whatever latest is, it's going to install that from the Salt Bootstrap script. And then it's running in EC2. So if I have platforms, if I'm doing testing both in EC2 and on-prem and VMware and Azure too, then I can name those differently just so I can test them. So then it'll start up, it creates the VM, it applies the state, and I snipped all that out of there. And then it runs the state test. So that test that we just looked at, here's the output from it from a text perspective. The file temp_rel7 exists and has our junk file data text inside it. So it finished, everything passed and worked, and so our state, very basic state of just managing a file did what we expected. So the kind of the key here is writing those tests, really, when it boils down to it. So it does take a lot of effort to create those, because not only when you write a state, then you've got to write a test to go with it to check it. So you may even have more tests for one state. It may not be one-to-one. If you're managing a file and you're interested in multiple lines in it, you may have 5 RSpec tests or server spec tests to test that one managed file state. So it's kind of a good and a bad to it. So it allows us to see, test equals true is nice, that I can see, it needs to change this file. And you may or may not get a diff on it depending on what else is changing. If I've written my RSpec test and specifically on the content I'm looking for, then I can actually report, almost like the SecOps tool that they've come out with. I can actually report, because you can run RSpec manually. It doesn't have to be done through through Test Kitchen. I can run RSpec manually against a system out in the wild and compare it to my tests that I have, so I can go see exactly which tests it failed or didn't pass from either a salt perspective of running apply with test equals true and see it from a salt output perspective, or I could use RSpec to test them all and see it from an RSpec test perspective that shows it all in a different language, a different way of looking at it. So, okay, so pros and cons of Test Kitchen. The biggest pro is it validates end-to-end the state. So it's going to check rendering, because if it can't render, then it can't apply the state. It's going to check that it applies with no errors, and then whatever tests you write to validate it, it's going to check those. The tests, like I mentioned, could be used as external auditing, so you can use those tests against your infrastructure as well, your running infrastructure. As on top of using them to test that things work, I can go run those tests against a machine out in the wild and make sure that all my tests pass, and I get more of I'm able to get either a report that could be put into something like Elasticsearch that you could, create visualizations on a little easier than you can with salt output, or more like a human readable documentation output of like my setup of this. Like we have states, talking about NIST, we have states like 800.171, control 2.7.3. We meet this control by setting these settings, whatever it is. And so we have tests that are described that way. So it says describe NIST control 800.171, 2.7.3. This file should be this config setting should be this. And so we're able to report on those types of things using RSpec as well as using SALT. So it gives us just an outside check, if you will. And then Test Kitchen, it handles just about everything for us. So like I said, it creates a platform for me. I don't have to go spin up a test VM, install Salt on it, or I could use Salt Cloud obviously or something like that and do all these steps. But Test Kitchen just kind of bundles it all up into one meta framework for doing the testing infrastructure. So it just does a lot of that work for me, and which from my perspective is nice. I like building things, but then I also like using tools that are already set up to do something for me too. It does, so it does have some cons. It's not necessarily fast, depending on how big your state tree is. If you've got a lot of data, because it's going to copy your state tree to that minion. It actually runs the minion in masterless mode and applies the state that you tell it to. So it's going to copy your entire state tree out to that minion for it to run the state that you tell it to. So if your state tree is huge, then you're going to pay a little bit of penalty there, especially on the Windows side, because it uses WinRM, which isn't efficient at all for copying files. But you can do, like once you get into the automation of it, you can do concurrency. You can run multiple platforms and suites all at the same time. So you kind of bring that back down to a manageable level. I think we run, I'd say probably 10 different state platform combinations for like this kind of the states that I'm really in charge of. And they take about an hour to run all 10 of them. So that runs states against multiple different versions of Linux and Windows to test all that stuff. So it definitely requires more effort because your developers have to write those tests. They have to write a state, and then they have to write a test. Or if you can get them to do test-driven development, they have to write a test and then write a state to make it work. So that's definitely the biggest struggle, in my opinion, is getting your SALT developers, the people that write states, to actually use it. So it's actually one of the reasons I did this talk, was to try to help evangelize that to our own group of people by bringing, having to write this presentation. So, and finally, like PyTest, it's only as good as the test you write. So if you do 10 things in your state and you only test one of them, then you're not necessarily doing that much for yourself. So. Okay, so now, automation, it only actually gets one slide, which is unfortunate. But really, once you have it set up and working for you, you can automate it fairly simply or easily if you do something like Jenkins. When a user commits to our Salt repo, we have a post-commit hook that then starts our Jenkins job, and then our Jenkins job runs the pytest tests with this command right here, which just tells it to run all the Python tests in there, and then the JUnit, in JUnit output, and then consume that JUnit file. So then if you're familiar with Jenkins, you get a pretty graph that says we ran 500 tests and they were all successful or what have you. So same with Test Kitchen. You simply have to run the kitchen, and it'd probably more likely be kitchen test instead of kitchen verify. I actually just copied that straight out of our repo, and the reason it's verified just real fast is because we do on-prem testing in VMware too, and the plugin for VMware periodically it'll create the VM and set it all up, but then it fails out, and so you're left with a VM. So we do it in 2 steps, so we can run that create until we get one good, and then we run verify, and then we destroy it. So that's why it says kitchen verify there instead of like just kitchen test. If you're in AWS or one of the others like that, just running kitchen test generally works perfectly fine. So, and then again, JUnit consumes the JUnit file that kitchen would output to, and that would be controlled like with pytest. The JUnit output is the JUnit XML argument. With kitchen, it would be in your kitchen YML file, telling it to output to the RSpec JUnit formatter, so you get a JUnit file. Okay, so fast and furious there. The summary here is that we've got a lot of different tools at our disposal, that we can test with. Hopefully, you find it, maybe see that one may be useful for your environment, whether that's PyTest or Test Kitchen. And then, some, like PyTest, we can just bolt it on with cookie cutters or creating tests that are automatic. I didn't mention it, it skipped my mind, I apologize. So PyTest can also generate tests, so that parameterized piece that we showed in the PyTest output, where we said Red Hat 7, Windows 2012, you can generate that as well. So I don't necessarily need a PyTest test file for every state I want to test. I can actually just generate it if you wanted to. We've got a lot of old states that don't always render except in very specific situations, and so that's why we use the specific test file method. But you can actually, in your conf test .py, like os.walkthrough, find every SLS file and generate a test for it to say run it on whatever OS platforms you want it to. So the key things I hopefully you get out of this is that there's a lot of tools again that you can use to test, and hopefully you'll use them both in a manual way and a non-manual way. So whenever we were doing development, we do those tests. If I write a state, I'm going to go manually run Test Kitchen myself to make sure that it passed before I go stick it through the pipeline, and that way I know my state's good. But then if my formula or state is used by other people, then I'm not going to manually go test all their formulas for them. So then that's what the automation's for then. If mine's good from my perspective, then I commit it, then the pipeline runs it, and their tests then get executed, and it makes sure that I didn't break something of theirs because they're relying on me to provide something. So that's, again, another one of the, with Test Kitchen, the things that it can provide for you is that kind of dependency checking. If you're doing a lot of, like, I own the Java formula that installs Java in our environment the way we want it installed, and then I've got 10 people consuming the Java formula for their state. If I go make changes to Java, I could negatively impact them inadvertently, and so that way I can test my state, and then they have tests to make sure theirs works consuming that. Another thing that the Test Kitchen's really good for that I've found is refactoring. So if you write a state one way, you're managing a file or whatever, and then you realize you find that some whiz-bang state module that someone wrote that does it 5 times better. From my off the cuff, we had a bunch of file.manage states that we were doing, and then I discovered the file.serialize. I don't know if anybody uses file.serialize, but it's super helpful in templating or managing like specific types of files. And so we converted all of those from file.manage to file.serialize, and I automatically get the verification that my state's still doing what it wants using that different state module, because I'm able to run my tests against it, my kitchen tests that then go validate that actual file looks the way I want it to look. So, okay, we've got, looks like about 7 minutes, so hopefully there's some questions. I know, like I said, that was really fast, and yes, sir?
I wonder, you specified on your pytest some custom grain data. Were you switching pillar environment past custom pillar data as well?
So the question is, when we pass, I'll try to rephrase it properly, when we pass the custom grain data, are we also passing custom pillar data? And the answer is, it's possible. So I'll jump back to that slide for you here. So the argument there, we have, you can see in the parameterized, we have OS family, OS major release, and pillar. So that third pillar, we can pass pillar data in to test that our state renders with some arbitrary pillar data. So it's not consuming pillar data out of our pillar file system, our /serve pillar, but we're able to basically test the same thing of if I passed in, if my minion had this pillar data, would it render? And so that, yeah, good catch, I didn't mention that earlier. And all 3 of these, we're just passing none, we're not doing anything with pillar, but it gives you that capability too, yeah. So to test, not only does it render for that particular grain combo, but if I go specify specific pillar data, does it still render? Yes, sir. So the question is, have we investigated using containers instead of virtual machines? And the answer is yes. Really the biggest reason we're not is just because we have Windows too. And so the simplest thing is to just stay consistent. But there's a Test Kitchen plugin for Docker to create Docker containers and do all the same things. So you can definitely use containers in the same way. There's actually a blog post by a gentleman from Trivago where he's doing the same idea with pytest in containers. So he's taking a container, creating it, overriding the grains, and then doing a show SLS to see if his states render. So it's definitely doable, yeah, instead of using VMs. Yes, sir.
Do you have any complex tests where you set up multiple minions and masters?
So the question is, do we have any complex tests that set up multiple minions or masters? And my team doesn't, but we have done that, yeah. And so you do have to get a little more creative in that way of, maybe you run a verify to set up the first thing like a database. If it's got a multi-tier app, you could run a test verify, kitchen verify to set up the database, make sure it's good, load data into it, and then you could run a kitchen verify for the app layer, and then make sure that it connects back to that database and everything works. So it's definitely possible. It's just, it wouldn't be a single command to do multiple platform suite things. So you'd have to do some of that legwork yourself. Yeah.
So that Linux spec helper, is that actually included in the repository?
Yes, yeah, so the Linux spec helper is included, and so what that does, that's telling our spec how to connect to the VM. So like I mentioned, it all just uses SSH or WinRM depending on if it's Linux or Windows. And so I don't have to have any Ruby on the machines I'm testing. The Ruby all exists on the machine I'm testing from. So, and that's what the Linux spec helper does, is it tells our spec, you know, you're going to use SSH, you're going to use this key or this password or what have you, and that's how you're going to connect. So, I think there was another question over here. Maybe not. Shoot.
So for RSpec, when you're running it against production, do you actually have custom pillars inside of your formulas that mock what you would see or apply in production?
Good question. So the question is, if we run our RSpec tests against production, basically how are we handling pillar data? Because pillar data may affect how the tests need to be written, right? So actually, we have another spec helper that this is kind of a creative, if you will. You can get really, I'll put creative in quotes, but a creative way is we actually run pillar.items through RSpec, put that into a Ruby variable, and then pass that into our tests, that then our tests are parameterized exactly like our state is with defaults.yml, so they match one-to-one. So then we consume that pillar data and pass it into the test. So it's basically a custom test for any minion I want to use its own pillar data. That particular thing is not in the repo, but I can definitely, if you need it, I can share it. Yes, sir. So the question is, do we have anything for more complex orchestration and multiple machines? And from our perspective, no. But again, just like the answer to the other gentleman about multiple, you could do it. So you could use these same tools to stand up a master, and that then gets a beacon, or has a reactor. Sorry. Went blank there for a second, running, and then use another instance created to, that maybe uses a beacon to send something to that master, and then you could do those kinds of tests. You could do it, again, it may take some creativity on your side to make it happen. It's definitely more targeted towards just that a state applies. So that's definitely how the tools, at least from a test kitchen perspective, that's how the tools are definitely more laid out to do. Any others real quick before we go? All right. Thank you guys very much. Hopefully it was helpful.